Now let's talk about some example questions. So first you have a solid with on x squared plus y squared is equal to 4. That's a circle. And we have to find the cross section of an equilateral triangle. So we need to find the side since the formula for an area is side squared root 3 by 4. So we'll calculate y and the side is going to be 2 times y since it's an equilateral triangle. So the side will be 2y and that would become 2 times root 4 minus x squared. The limits are going to be from -2 to +2 since if you draw this circle, it has a radius of 4. So this is 2 and this is +2. So we are going to be integrating from this to this. Now we'll solve the integral, input all these values, and since the area also consists root 3 by 4, which is a constant, we'll take it out of the integral and we'll solve the answer to get 32 root 3 by 3. Now let's talk about the disk method, finding value using disk. So we're going to split this in two parts where we are talking about revolution around x and y axes, and the second is revolving around other axes or other equations. So this is how it basically looks like. We are going to have an equation, right? Let's say this is y is equal to x squared, and this is your x is equal to, sorry, this is y is equal to 0. So you're basically going to revolve y is equal to x squared around the x-axis, y is equal to 0, which will form a shape like a 3D cone, right? And to integrate the volume of this figure, we are going to be calculating the area of a disk like such. You're going to calculate the area of this disk, and we are going to be integrating it from whatever limits we are given, x coordinates from x1 to x2. So the general formula for it is pi times the integral of f of x whole squared. F of x in this case is x squared, which is whatever function is being revolved around the x or y axis times with respect to dx and the limits a to b, which are going to be the x coordinates. Now, if you are revolving around the y-axis, instead of f of x, we're going to write f of y, and we're going to integrate with respect to dy, and instead of a to b we are going to be integrating with limits c to d, which are going to be y coordinate limits, right, as mentioned. So now let's talk about revolving around other axes. So I've got I've got an equation y is equal to root x here and a line y is equal to 2, and we are going to be revolving y is equal to root x around y is equal to 2 to form a cone, and we're going to be calculating the volume of this cone. So here is the graph, right? Here's the equation y is equal to root x. Here is the line y is equal to 2, and this will form a cone-like figure. And this is the disk whose radius we'll calculate, right? And the formula becomes pi times r square, where r is the radius of the disk. And to calculate this radius, you are basically going to subtract the function, right? The primary function that is being revolved around something minus the axis. So right here, root x is being revolved around 2. So the radius becomes root x minus 2, and we will input this in place of f of x, integrate this as normal, and we'll get our answer as 7 pi by 6. Usually College Board will only ask you to set up the integral, but if it's easy to solve, they can also ask you to solve it, evaluate the integral, right? It may seem a bit confusing, but I have several other practice problems ahead, which will definitely make it clear. Okay, so now let's talk about something known as a washer method. So this is another way of finding the volume of volume when you're talking about revolving some function. So if you're revolving around x-axis or y-axis, we are supposed to follow these two functions, which is pi times the integral of f of x squared minus g of x squared with respect to dx, with limits of x coordinates or y coordinates, depends on whatever you're revolving around. This is for rotation around x-axis or y-axis strictly, right? So for example, I have a graph here of y is equal to x and y is equal to x squared, and we are going to be revolving the area bounded by these two curves around the x-axis to form a washer, like a figure that resembles a washer, right? It's not going to be a cone because the it's not simple area. It's area bounded by these two curves, right? If it was just y is equal to x, then or just y is equal to x square, it would resemble a cone, right? It would resemble something like this, or for y is equal to x square, it might resemble something like this, where, yeah, something like this. But for a washer, it's gonna look entirely different. You can imagine how it looks like. It's really hard to draw for me. But for a question like this, we are given the limits 0 to 1, input all the values, and since x is above x square at all points, as you can see, I'll just mark it. Let's say this maroonish color is x square, and since it's above x square at all points in since right, this is basically what happens when you revolve it. This is not the graph itself, but when you're in the first quadrant, your x is always above x square. So x becomes f of x and x square becomes g of x. And that results in 2 pi by 15 when you integrate it. Yeah, f of x is the top curve while g of x is the bottom curve. F of y is at the right while g of y is at the left. Of course, same point, note that. Now we are going to be talking about volumes with washer methods when you are revolving around other axes. So we have three equations here. Y is equal to 4x, y is equal to x squared, and we have a line y is equal to minus 2. So the first thing I'm going to do is find limits, which are going to be 0 to 4, because that's the area which is bounded by. So it's 0 to 4. And now we need to find the distance. We need to find r basically. So we are going to subtract 4x minus minus 2, which is 4x plus 2, x squared minus minus 2, which is x squared plus 2. This is the same way how we found the radius in the last disk method. We are basically doing that again, finding the radius, but for every individual function this time. And then we'll input this into the formula and we'll get our answer if you calculate it further. Right. Of course, the main thing is to practice, 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 right? And that is essentially what we're going to be doing right now. So I have a set of questions. You can pause the video, go through them yourselves, and you can come on to see the solution, right? Okay, so we have an equation of a semicircle here. Y is equal to root 9 minus x square and y is equal to 0. So and to rotate the area, uh, it should be area here. Yeah, so we have to rotate the area bounded by these two curves around the x-axis, and we need to find the volume of the figure formed. So the formula is, of course, pi times fx square minus gx square integral, and the limits are minus 3 to positive 3, since that's the radius of the semicircle on the x-axis, minus 3 to 3. We'll input the values, we'll solve the integral, and our answer should be 36 pi. Right, and since 9 minus x square, root 9 minus x square is always above the x-axis at all points between negative 3 to 3. Therefore, f of x is root 9 minus x square. That's the main thing that you should be careful about. And yeah, everything else is basic integration, which I'm hopeful you can already do. So we have got another graph here, y is equal to sec x and the x-axis. And again, we need to find the area bounded by these, and we need to rotate it around the x-axis. We have been given the limits minus pi by 4 to pi by 4, and we need to find the volume of the figure formed after rotating right around the x-axis. So we input the values. Sec x is always above, secant x is always above the x-axis at all points between the limits. So we'll input it as f of x, and we'll solve the integral. Tan x derivative is sec square x. Therefore, the integral for sec square x is tan x. So you don't need to solve the entire integral. This is a quick, easy way to remember. Solving this, we get 2 pi. Okay, so we have got y is equal to root of x upon root 5. and we have got an x is equal to 0, we need to find the volume that's bounded by the region when we rotate it from 1 to minus 1, y is equal to 1 to y is equal to minus 1 around the y-axis. So we're going to input the values and integrate it with respect to dx, right? Wrong. Because if you paid attention, we have to rotate around the y-axis. Therefore, as mentioned here, we have to rotate around the y-axis and not the x-axis. So we cannot integrate it with respect to dx. We can't use functions which are in x. We need to use functions with respect to y, and we need to integrate it with respect to y. So we're going to write the equation in y, input this, integrate it with respect to dy, and input all the limits, and we'll get the answer as 2 pi. Now, a bit of formula here, which is the length of a curve for a function f of x is continuous and differentiable on interval a to b, then the length of y is equal to fx from a to b will be this. Right, memorize this formula, of course. So let's start the drill for applications of integration. Need to find the area between x-axis and y is equal to cos x from these limits. Right, I have drawn the diagram for you, and this is how your integral should be. You're already given the limits. Solve this, and your answer should be 1. Right. Now, uh, what's the video? Solve. Yeah. So area between y is equal to 5 and y is equal to x square plus 1. So this is the quadratic. Y is equal to x square plus 1 in maroon and y is equal to 5 in pink. So we need to find this area, and we are basically going to integrate it horizontally. You can also integrate it vertically as you wish. So, oh wait, we have to integrate it horizontally. This is wrong. It should be uh yeah. So you have to integrate it like this. And you integrate it and you get the answer as 32 by 3. Now this is the next question. Pause the video and solve. Okay, so find the area between this quadratic and this line. So this time I've drawn it correctly. We have to integrate it as normal. The quadratic is above the line at all points, so that is f of x, and the line is going to be g of x, and we are going to integrate this, and our answer should be 36. Okay, pause the video and solve. Okay, so we have to find the area between y-axis and x is equal to 25 minus y square. And this time we're going to be integrating vertically. So the quadratic is always to the right of y-axis. So that's going to be your f of y, and your y-axis is going to be g of y. Integrated, and your answer should be 500 by 3. Well, the appropriate limits being from minus 5 to 5, which are the y-intercepts of the uh, area bounded by these two curves. Okay, pause the video and solve. Okay, so we need to find the area between the x-axis, the x is equal to root y and x is equal to 4. So we need to basically find this area right here. We need to integrate this. Yeah. So there are two methods to do this. We can either integrate it horizontally or vertically. I have written both of these answer here. So yeah, I recommend you practice both of them since it's only gonna help you, right? So with functions of x, your answer is going to be the same, 64 by 3, but this is how your integral should be set up. And if you're integrating it vertically, this is how your integral should be set up. And your answer is, of course, going to be the same, 64 by 3. So you can double check as well, right? Okay, so I've given you the diagram as well. Solve this question. Okay, so volume of the solid that results when area bounded by y is equal to 1 by x is equal to 1 and x is equal to 4, and y is equal to 0 is revolved around the y-axis. So this time we are talking about the volume. So we have to integrate the area. So we're going to use a formula. And of course, this time I have integrated it with respect to x only. And if you have integrated it with respect to y, the answer will of course be the same. But if you have integrated with respect to x, which is a bit easier in my opinion, this is how your integral should turn out, and your answer should be, of course, 3 by 4. Seventh question. Okay, so solve it. Pause the video and solve. Okay, so the volume of a solid bounded by x is equal to whole root 1 plus y, x is equal to 0, and y is equal to 3 is revolved around the y-axis. So this time it will form a sort of a right angle down cone. And this is how your integral should be set up if you are integrating with respect to y. Right, I've integrated with respect to x here, and now we are integrating it with respect to y. Solving this, your answer should be 8 pi, right? And your limits should be from -2 to 2, which are going to be the point of intersections. Okay, so pi coordinates are the point of intersections, of course. Okay, eighth question. I think this is the penultimate question, second last question. I don't remember. So the volume of the solid that results between y is equal to x squared plus 1, y is equal to x plus 3 is revolved around the x-axis. So this is a Washer method question, and this is how you're going to solve it. This is basically what your washer is going to kind of look like, and this is what happens when you revolve this right here. This is how it's going to look like, and you can imagine it revolving like, and it will form a figure like this. Like this is what you mean by a washer. So we integrate this, x plus 3 is always above x squared plus 1, and we integrate this with the respective limits that are the point of intersections of the x coordinates bounded by the region, and solve this, and we get our answer as 117 pi by 5. Now, this is, I think, yeah, this is the last question. So pause the video and solve it. Volume of a solid bounded by region x is cosec y times and y is equal to pi by 4 and y is equal to 3 pi by 4 and x is equal to 0 revolves around the y-axis. So this is how your diagram should look like. This is your cosec y, this is pi by 4, this is 3 pi by 4, and this is of course your x is equal to 0 or y-axis. So I'm integrating with respect to y here, right? So I'm going to take all the functions in y, and since that's going to be a lot easier, we're going to input all the limits, pi by 4 to 3 pi by 4, and since the derivative of cot x is minus cos x square, therefore the integral of cos x square is minus cot x. You basically take this here and you integrate and you get this answer as minus cot x. So that's how you speed up your calculations, and your answer should be 2 pi. And that is it for today's video. Thank you for watching. And in the next session, we are going to be doing vector valued functions, parametric equations, and of course, in my opinion, the hardest and the most interesting part of AP Calc VC, polar curves, at least after Washer methods. So be sure to like and subscribe, and I hope to meet you in the next video.